So now that we've looked at part A, we're ready for part B. Now, in part B, once again, I'm going to start off with my average rate of change. And once again, the average rate of change is delta y over delta x. So for the first two rows here, then, delta y is going to be 3 minus 3 halves divided by 0 minus negative 1. 0 minus negative 1, we're adding there. So it ends up being 3 halves over 1, which is 3 halves. And then for my next two rows, delta y over delta x would be 6 minus 3 over 1 minus 0. That ends up being 3. At this point, I don't need to do any more calculations for the average rate of change. The whole idea is to find the column, either average rate of change or the ratio of consecutive outputs, where we end up getting constants. If I have 3 halves for one of these and 3 for the other, I know that these are not going to end up being the constant pieces. So average rate of change, I'm done with that column because I know that I'm not getting the same number for each delta y over delta x. So with that in mind then, let's see if the ratio of consecutive outputs ends up being the one that is the constant column. So again, ratio of consecutive outputs, I'm interested in the y values. So I have a y value of 3 and a y value of 3 halves. That means we're going to have 3 divided by 3 halves. Now remember that when you are dividing by a fraction, that's equivalent to multiplying by its reciprocal. So this is the same then as 3 times, and then the reciprocal of 3 halves is 2/3. Now, as you look at this multiplication problem, remember that 3 can be written so it looks more like a fraction by writing it as 3 over 1. Cancel the 3's here, and we end up getting the number 2. So the ratio of 3 and 3 halves ends up being the number 2. So now that we have that then, let's see if we keep on going down the table if we get a constant ratio. Well, here we have 6 divided by 3. That one's a much easier calculation. And yes, 6 divided by 3 is 2. 12 divided by 6, also 2. And 24 divided by 12, also 2. So this time, it's the ratio of consecutive outputs, which is a constant. And in this case, it happens to be the constant of 2. What you have to remember then is, once again, that statement from above, that if the ratio of consecutive outputs is constant, then the function is exponential. So let's go ahead and circle that. So this is an exponential function. Now that we have that, we can actually write down the functional notation for this problem. So remember from above, exponential functions in general can be written in the form y equals c times a to the x. Now, before, I simply said c was a constant, but in fact, c is something special. C is the initial value. And the initial value is the value associated with the x value of 0. So the initial value is the same as f of 0. So now that we have that information, let's figure out the last piece that we need, and then we're going to have our function. A here, in fact, is the ratio of consecutive outputs, which was constant throughout this particular problem. So let's make that comment as well. It is the ratio we found. So let's put those two pieces together. And again, I'll write it in functional notation. So we have f of x equals, once again, c is the initial value. So I'm going to find then the spot here where we have an x value of 0, and the y value associated with that is 3. So we're going to have 3 times, a is the ratio that we found that was constant here, 2, and then we have our exponential function, so that means our exponent is going to be our variable. So it's going to be x. So in this case, our exponential function then is f of x equals 3 times 2 to the x.